Hello guys, today we're gonna solve some exponential equations with logarithm. We already saw some example where we can solve exponential equation without logarithm. But in those case, if we can manage to have the same base in both sides and we have exponent in both sides, we just can just we just can take those exponent and make an equality with them. But this is not always possible. That's why you have to know how to solve exponential equations with logarithm. Understand, when we are dealing exponential equation with logarithm, the variable x is in the exponent, so we have to find a way, to put these variable down in order to solve the equation. All those cases, the variable x is upstairs, we have to put it downstairs. Okay, so we're gonna try to solve them by using logarithm. Let's try to remember some property. Remember, this video is a long video, but you can click in whatever sections you want, whatever the equations. We have 6 equations here. You can click whatever the equations that you want the solutions. You can click on the introduction or some but it's really important also to click on the section about the property, because you're going to use those property in order to solve the equations. Let's try to remember those property. Property number 1, if you have exponent inside logarithm, you can make a transformation to make it in form of multiplications. Like this example, the exponent n is becoming in front of the log n times log base b of m. This is one of those property that you will be using when dealing with exponential equation. I put an example here, log base 2. You see the exponent x now, it's right here. So you have x log base 2 of 3. So you just move the exponent. That's the property. This property I use it. But for this example, you end up x log base 2 of 3. So you are saying, what the hell? Where in my calculator I'm going to compute log base 2 of 3? Some special scientific calculator have base, most of base 2, but most of them have natural logarithm ln or log, which is log base 10. So you can use the natural logarithm by using the fourth property, change of base. If I have log base b of c,
I can with like natural logarithm of c over natural logarithm of b. So log base 2 of 3 can be like, it can be like natural logarithm of 3, right? It's natural logarithm of 3 over natural logarithm of 2. Okay, that's the way to use your calculator to find this value. Okay, but this is a property also, change of base. If you have log base b of c, it's gonna be natural logarithm of c over natural logarithm of b. But by the way, it could be also you have log also. The log that you have in your calculator is log base 10. Okay, you can use log base 10 of 3 over log base 10 of 2 also. We call this change of base. You can use this. Also understand, log base b of b, whatever the base, log base b of b is 1. Log base 10 of 10 is 1. Log base 2 of 2 is 1. That's a general property. Also, this property, that's really interesting. Log base b of b to the power of x equal x. So if you have log base b and you have the same base with some power, you just take the exponent. That's really interesting. That's one of the best way to get rid, of the base in order to have only the exponent. And this property can be explained by those two. Since if I have to use the first one, I would say it is gonna be x time log base b of e. So it's gonna be x time 1. You understand? By using those first two property, you can easily understand why log base b of b to the power of x equal 1, since log base b of b to the power of x is like we say n time. It's going to be x time log base b of b, or log base b of p equal 1, x by 1, x time 1 equal x.
That's it. I got an example here. I got these expressions. Log base 3 of 3 to the power of x plus 1 equal x plus 1. Look, remember the third property is really interesting, so that help you get rid of the base in order to have only x. That's really important, the third property. Okay, I emphasize the third property is really important when you are solving exponential equations. So it help you get rid of the base in order to have only the exponent. So when you are solving equation with exponent, just use the same base like that you have in your exponential equations. And the last one help you because most of the time in your calculator you don't have log base 2 3 log base 2 log base 5. You only have ln and log. Ln is if you want have log base like this on log base 3 of 3, you're gonna just change the base like log base 2 over log base 2. So you're gonna solve this first, right? Put it in parentheses, put this in parentheses. Okay, you make the divisions. Okay, remember ln is log base e. This is the natural logarithm. That means the base is 2.71. okay, it's also a logarithm, but the base is e. But most of the time we don't write log base e, we just write ln. Okay, now let's go back to our problem equation. We have like uh, 4 equations. Let's go to the first one. Okay, welcome to the first equation. We have, this is really easy. I have 10 to the power of 2x equal 52. So what I'm gonna do here, I'm trying to get only 2x. Like I say, I want to put this 2x down. So what I'm gonna do, I'm gonna just, since the base is 10, I'm gonna use the same base, log base 10. Log base 10. I use 10 like base because it's 10 to the power of 2x. Okay, so understand in your calculator when you see log is log base 10. Okay, but generally log you have to state what is the base. But for your calculator, when they say log, they assume is log base 10. But scientifically, log you have to state what is the base. Okay, so log base 10, okay, of 10 to the power of, so I compute log of both sides. Okay, to the power of x, log base 10 to the left, log base 10 to the right. Okay, log base 10 in both sides. That's why I did. Okay, log base 10 of 52. Okay, you see what I did? I just, what you may say, why I choose log base 10? Why choose log base 2 or log base 3? I choose log base 10 purposely because I see the base is 10. I just want to go fast in order to get rid of the base, because there is property that say log base b of b to the power of x equal x. So I'm gonna say quickly this equal to x. This equal to x. I get rid of the base. To x equal log base 10, right? Log base 10 of 52. Okay, that's it. So now you can use your calculator, because the sign you see, this sign that you see on your calculator, the sign of log. So guys, if you want to evaluate log base 10 of 50, you can use this symbol on your calculator, log. So this symbol log mean log base 10. Okay, just compute log base 52. This gives you log base 10 of 50, because they use it for log base 10. So on your calculator you only have log base 10 and log base e, ln. Okay, so you only have log base e, which is ln, the natural logarithm, and log base 10, which is this one. So you can just log 50 52 give you log base 10 of 52. So you will get this result. And finally, if you want the final result, you're gonna have like you're gonna end up with x. You're gonna end up with, for your final result, you're gonna end up with x equal log base 10 of 52 over 2. Okay, that's it. Okay, but remember, if you have log base 3, log base 5, you can evaluate it by changing the logarithm to natural logarithm. So that's for the first equations. Now we are in the second equations. What we're gonna do, we're gonna try to isolate the exponential equation to the left. So we want to have only 2 to the power of x in the left side. So I will have like 2 to the power of x plus 4 equal 350 over 3. Okay, is what we got for the. Okay, so we end up with this. Now understand, we want to get rid of the base 2 in order to have only x plus 4, because we want to solve the equations. Remember, you're gonna use log base 2, okay, of both sides, because you want to get rid of this base. So I'm gonna have like log base 2, right? Log base 2 of 2 to the power of x plus 4, right, equal 350 over 3. No, excuse me, log of both sides. Okay, so we have to compute log of both sides. Log to the left, log to the right. Log base 2 of log base 2 of 225. By the way, you can write 200 300 250, excuse me, 250 divided by, if I have 200 if I have 350 divided by 3, this equal 116. Okay, let's say is log okay, let's say it's like 250 over 3. So my result gonna be log base 2 of 2 to the power of x plus 4 equal x plus 4. I get rid of the base. Remember the formula, log base b of b to the power of x equal x. So this equal x plus 4 equal log base 2 of 116 by making the divisions. 350 over 3 is 116.66 approximately. Okay, since I want to know x, so I have to evaluate this log base 2 of 116.60. okay, log base 2 of this, in your calculator there is no log base 2. Remember, you have only ln, which is the natural logarithm, and log, the log is log base 10. okay, so in order to compute this, we just
In fact, if you want to compute this, you're just gonna write it you're gonna change the base. It's like you're gonna use the natural logarithm of 116.66 over the divisions over the natural logarithm of 2. If you want to evaluate this, you're going to use the natural logarithm like this. But there is some scientific calculator that have this. Also, you can go on the web if you want to compute it. But that's the way to compute it with your calculator. Remember to put a parenthesis here. Remember to put a parenthesis here. Okay? That will give you a value. And finally, x equal, so this value, you're going to minus 4 is going to be log base 2 of 116.66, okay, minus 4. Okay, so the value you find here, you're gonna put it here. Okay, you're gonna put it here and then minus 4. Okay, now let's go to the third equations. You got this one. Okay, for this equation, this is the same way. We're gonna manage to isolate the exponential equations to the left. Okay, so what I'm gonna do, I know if I want e to the power of x only, I want it to the left. So this is gonna equal to 115 minus 5 divided by 2. Okay, I just make one operation. I hope you understand. I just get rid of the 5 here, minus 5 on both sides, and then I divide both sides by 2. Okay, that's what I did, and then I end up with e to the power of x equal 115 minus 5 equal 110 divided by 2 equal 55. Okay, now I isolate the exponential on the left and I end up with a number. What did I remember? I want to have x. I want to get rid of the exponential. The base is e. I'm gonna use log base e of both sides. Remember, log base e is what we call the natural logarithm. Now, generally, when you say log base e, generally speaking, we just write ln, which is the natural logarithm, ln. So instead of log base e of this one, I just write ln. That means the natural logarithm of e to the power of x equal the natural logarithm. So I just choose natural logarithm of both sides. Why I choose natural logarithm in this case? Because I have my base. My base is the exponential, is e, the exponential. So remember, log base e, we call it natural logarithm. That's why in this case specifically I use the natural. So I know natural logarithm of e to the power of x equal x. You understand why it is equal? Because the base here is e. Okay, or the formula say log base b of b to the power of x equal x. This equal x, and I'm just going to use your scientific calculator to compute this. Just use ln 55 and then you're done. That's it. Use, because you have natural logarithm on your calculator. Okay, that's it. Let's go to this one. What about this one?
what we're gonna do here, same stuff. uh, uh, Remember, uh, this equal, okay, this, for this example, we already isolate, right? We already isolate the exponential equation. We can use log base 1000 if we want here. It's up to us, okay? It's up to us. We may choose to use log 1000. In this case, we're gonna have the sum solutions, okay? That means I can use log 1000 of both sides. But remember, you just can't divide by 1000. That's not possible because you got this, that's an exponent, okay? You don't have 1000 time for it. It's the exponent, so you just can choose divide by 1000. It's not possible, okay? So here, according to the method that we've done, we should use like log base 1000 of, that means we should use log base 1000 of this one equal log base 1000 of this one. We're gonna have it, okay? But I think it's awkward, too many number for log base of 1000. That's why I prefer to write this like 10 10 to the power of 3. I write it differently, you see. That's 1000. I put in another form. It's gonna be easier for me. Time 0.2x. You see what I did? I just write 1000 in another form so that I can use the base 10 instead of the base 1000. So it just base 1000. So I just make a simplifications, okay? So what I'm gonna do here, I'm gonna use, I got all these as an exponent. Now I can use log base 10 of both sides. Log I can use log base 10 of both sides. Log base 10 of 10 to the power of, when I multiply this, is this gonna give me like 3 times 12 is 36, right? It's gonna be 36x, right? Okay, log base 10 of 10 to the power of 10, 36 to the power of 0.36x. The log base 10 of both sides. I'm gonna have log base 10 also to the right side. Log base 10 of 25,000. Excuse me, because this is, I have a problem of this. 25,000. Okay, so now log base 10. Remember, I told you in your calculator, when you see log, it just means log base 10. Okay, log base 10 of this log. So I'm just gonna have like, since I have the same base, log base 10 of 10 to the power of 0.36x. So this gonna be give me like 0.36x. Okay, so in your calculator, you just can use log. Just compute log 25,000. This is, by the way, this is 25,000. Okay, that's just a mistake for my writing. This is 20. This is just 25,000. Okay, this is 25,000. So you're just gonna compute log 25,000. This is gonna give you log base 10 of 25,000, and then you're just gonna divide what you find. So x gonna equal to what you find. I don't know what is it when you compute it on your calculator, and you're gonna divide it. You're gonna just divide it by 0.36. That's it. Okay. Now we're gonna solve the fifth equations. The strategy is to try to isolate the exponential expressions. That's what we're gonna try to do. So first of all, uh, yeah, remember these properties. We have 12 over 6 equal 2. So 12 equals 6 times 2. So that's the same thing that we're gonna try to do here. Like 4,000, okay? 4,000 equal 5 times 5 times 5 times 2. Okay, 2. This is 2, right? 5 times 2.
Can you open it?
Excuse me, huh? There is some.
Can you open the safe?
So
What's this? Yeah.
excuse me for this.
This one.
So it's
Okay,
5 times
open it. It's like, oh.
2
Dino!
plus 7 to the power of x plus 1. Okay?
That's purple.
Okay, now we're gonna reduce these expressions. It's like 4,000 equal, by reducing the expressions, we're gonna have 4,000 equal 5 times 2 is 10. 10 plus what? Plus 5 times 7 to the power of x plus 1. By the way, we can't write 35 here. It's not possible, okay? It's not possible here to write 35 to the power of 35 to the power of x plus 1. It's not possible, okay? Since 7 it would have a power, okay? X plus 1. We still have x plus 1. Okay? So we're gonna just subtract 10 in. Here we have like 3,900, 3,990, right? 3,990, and then here I have like 5 times this, okay? So here I would only have this 5 times this, okay? 5 times 7 to the power of x plus 1. So in order to have 7 to the power of x plus 1, I have to divide by 5 both sides. So I have to divide by both sides by 5, right? So I will have like 3,990 over 5 equal 7 to the power of x plus 1. X plus 1. Okay? So now what I'm gonna do, it's really easy. Since I need to have like only x plus 1, I need to have only x plus 1. I'm gonna use like log base 7 in both sides, right? So I'm gonna use log base 7 in both sides.
So I'm gonna have like, first of all, let's have the real value of this. 3,990 divided by 5, divided by 5, 798. I had my nephew that's giving me trouble. He's making noise. Excuse me for this video. So 798 equal 7 to the power of x plus 1. Okay, so I have to compute log of both sides. Okay, log of both sides. So I will have log base 7. Why I should say base 7? Since I have the base is 7, that's why I compute log base 7 of both sides. Log base 7 of 798 equal log base 7 of 7 to the power of x plus 1. Log base 7 of 7 to the power of x plus 1. So here, remember this property, log base b to the power of log base b of b to the power of b to the power of x equal x. So I'm going to have only x plus 1 here. So I'm going to compute this. Remember when we have, because in your calculator you don't have log base 7. So that's why I'm going to change the logarithm. Remember what I told you, if you have log base b of c, you just can write natural logarithm of c over natural logarithm of b. So I'm going to write this like natural logarithm of 798, okay, over natural logarithm of 7 over natural logarithm of 7. Okay, so that's how to evaluate this part. And on the right, I'm just going to have x plus 1. X plus 1. Okay, I'm just going to have x plus 1. So by computing this, I don't know what you're going to find. When you compute the natural log, you're going to find some value. And I'm just going to minus by 1 to get x. Okay, so now let's go to the last, which is the toughest. We're going to work with. So we are going to try to solve these last equations. So we have here like e to the power of 2x minus 5 e to the power of x plus 6 equals 0. So the problem is, it's really we have two exponential equations. We just can't isolate them. So we can't use the same technique. We have to use another one. So if we take time to make some observations, e to the power of 2x is e to the power of x times e to the power of x. You see what I mean? So it's like, this is like this squared. It's like e to the power of x squared. Okay, so that's why we can make a transformation in this by trying to choose the method of substitutions. How are we gonna do? We're just gonna put, let's say, e to the power of x, right? I say e to the power of x equal y. Okay, I put e to the power of x equal y. Okay, I'm gonna resolve it like on equations. Okay, if e to the power of x equal y, so when I have e to the power of 2x, this is gonna be like y squared. You see what I mean? So if you have y squared, what we're gonna do is like e to the power of x times e to the power of x, which is e to the power of 2x. Okay, let me write it for you. So if I have e to the power of x, right, time e to the power of x. Okay, so this is like
e to the power of 2x, e to the power of 2x. Okay, that's why here we put y squared minus 5y minus 5y plus 6 equals 0. So now it's really easy. I have an equations of I have just to solve these equations. So solving this equation, this is another chapter. You should know how to solve it, and we'll do other video about how to solve those kind of equations. But there is a fast method here. Since I have, by making, I can say like easily, this is y minus this is the product, minus 2 y minus 2 time y minus 3. Okay, there's a method to do it. That's another chapter. Equals 0. This is really easy. Okay, so to give you an idea, this is the S and this is the P. I see 2 times 3 equals plus 6, and minus 2y minus 3y give me minus 5y. Okay, minus 5y. That's the way to do it. By solving these, I will have like x minus 2 equals 0. Excuse me, y minus 2 equals 0, y minus 2 equals 0. I will end up with y equal 2. Okay, y equal to 2 value, and y equal 3. That's the solutions. Y equal 3. Okay, so since I have y equal 2, y equal 3, so I will have e to the power of x equal 2, right? And e to the power of x also equal 3. And I will solve it the way I used to solve it, right? So I will have like e to the power of x equal 2 and e to the power of x equal 3. Remember how we're gonna solve when we got this kind of situations. What we're gonna do, we're just gonna try to compute log of both sides. In this case, it's gonna be log base e ln e of e to the power of x, which equal x, and ln e of 2. That's what we're gonna do in these situations. Okay, this is gonna be really easy. Unify y and y equal to y equal to. I'm just gonna put it y here. E to the power of x equal to, right? E to the power of x equal to. I need the x. I'm gonna compute natural logarithm of both sides. Natural logarithm of e to the power of x gonna be x. Natural logarithm of 2, I don't know, use your calculator, you're gonna get it. Also, you're gonna have the other solution, e to the power of x equal 3. Natural logarithm of e to the power of x equal x. Natural logarithm of 3. Use your calculator, you will tell me what you find. Okay, that's the way to do it. So I think that was a long video. See you for another video, and let's go channel for more videos.